Today I'm going to talk a little bit about some of the challenges that Elsevier has been facing trying to pivot from a publishing company to a data science company. Obviously, I'm not Michelle, but I am going to talk about Michelle's work. So let me start with a prediction. AI will come. AI will change the world. Just like today, I'm guessing nobody in this room has any doubts on who would win a chess game, a human or a computer. I suspect that in the future, the not too far away future, the same is going to be true for driving a car, interpreting an image, helping patients survive cancer. This is statistics from PwC that identifies in billions of dollars how much money is out there to be made out of AI. So let me tell you a little bit about Elsevier and the transitions we've been through over the past few decades. Before we go there, Elsevier is part of a larger group called the RELX Group. The other members of the family include Reed Exhibitions, but you probably know these guys better as the folks who organize Comic-Con. LexisNexis is a company that does information processing for legal documents, helping attorneys and helping judges make the best legal decisions. RBI, or Reed Business Information, deals with risk. And then, of course, there's Elsevier, and most of our work has to do with the research, life sciences, healthcare domains. We've got in total over 7,900 employees all over the world. We operate in 170 countries. We published over 2,500 journals, 30,000 books, and we serve over 3,500 institutions. And 2018 revenue was around $8 billion. So we're big. And who do we serve? We serve clinicians, we serve nurses, and we serve researchers. They all have decision-making problems, and this is the sort of thing we're trying to help them do. So the way we do that is we combine content, evidence, with analytics in order to deliver the right information to them at the right time in the right context. So let me tell you a little bit about the history of Elsevier. We started with content a long time ago. The company is 130 years old. So for many, many years, for decades, Elsevier has published mostly books, journals, Grey's Anatomy, which you may be familiar with, Woodhead, The Fundamentals, Cell, the journal, Lancet, the journal. These are all flagship products that Elsevier has published over the years. Anybody who has trained in nursing knows about Elsevier because most of the books they were trained on were published by Elsevier. Same is true for the medical field as well. Elsevier publishes many, many books that help medical students get through medical school. But when the world became digital, we had to make that transformation as well. So nowadays, we are no longer a publishing company. We are a company that lets researchers, lets doctors find the most relevant content for their needs. We call this stage the search stage. So we were forced to make this transition because the internet became widespread, and so nobody wanted physical copies of journals anymore, or very few people did. So ebooks and digital papers were all the rage, and that created the need for platforms, search platforms that would let people discover content dynamically. We're now transitioning into yet a new stage, and this is what we call the do stage. So turns out there's way more papers than any doctor or any researcher can read in any given day being published. And so what our customers actually need is decision-making tools. Now, those decision-making tools should be able to understand their needs, understand their questions, and give them the right answer. But it's not enough to give our customers the right answer. They have to trust that it's the right answer. we need to also give them evidence that this is the right answer. We have to show them that we went through these many papers and these many books, and we surface the right information given the question that you're asking and what we know about you as the customer. So I'm going to talk a little bit about the Science Direct topics, but one of the key points that I'm trying to make is we're really moving into a world where people are supported in their decision-making process. And we don't call this artificial intelligence. This is more like augmented intelligence. Because at the end of the day, human beings are still making the decisions on what experiments to run, what drugs to use to treat a patient. But here's the challenge we've faced, and we're still facing it on a daily basis. So before we made this transition to analytics, we used to hire contractors to extract information from text. Now, it was a brute force approach, but should never underestimate the value of brute force. So we would hire them to process the information in the back end, and they would then create structured information to power the tools to help the decision-making process. But for each product, because we had to hire experts from many different fields, there were chemists, biologists, doctors, each product had its own quality metrics. Each product has its own tools and content enrichment tools. So this was quite a bit of a challenge because we wanted the ability to have a single quality metric across the organization. So in some cases, we had our customers very unhappy about the amount of content they had for the decision-making process, and our contractors were saying, oh, but we have 99% accuracy. What are you saying? The customers are complaining. Right? So it turned out it was the way that our contractors were thinking about quality metrics that was not shared across the organization. Beyond that, as we were in this process, we were not able to iterate. We were not able to check what is the best workflow, what is the best way to actually get structured content out of text and to put it on the tools. We couldn't incorporate user behavior. There was not a lot of automation we could do. We couldn't improve the curation process because it was all manual and devised by the contractors themselves. So let me give you a few use cases of how we got around these challenges. So the first use case I want to talk about is reaxes. Anybody here from the chemistry domain? Anybody works in pharma? Wow. Oh, one person. There you go. This is Boston. So reaxes is a tool that's used by chemists. Chemists in pharma companies, they have a need to know what chemicals, what compounds have been invented, created, so that they don't go ahead and create the same compound or invent the same compound. And reaxes is a tool that gives them access to that. So they can search for compounds by their name, by their chemical structure, by their uses. And another thing they get out of reaxes as well is if a compound has been invented, how to create it, how to put together the right chemicals in order to create that compound. But the information that we were putting into reaxes came from these contractors I was telling you about. So they would read papers and they would read patents and then they would create the information to make it available through reaxes. So this was very cost intensive and it's not scalable. Because if we wanted to increase the number of patents we were scraping data from on a daily basis, we would just essentially have to hire more contractors with no guarantees that the quality of the data would remain the same. So we started experimenting with a few data analytics approaches. Can we automate the extraction of what became known as excerptions? Can we automate the excerptions from literature, from patents, from books, from scientific publications? So what we tried was we used a simple support vector machine classifier, right? So given sentences that we were collecting from books and articles and patents, we essentially separated documents into relevant or irrelevant. So that was building a classifier, as I'm sure most of you know, is very, very easy. It's very easy to get right. Then came the more difficult part. So given that we now know which sentences have molecules, how do we extract the actual molecule from the sentence? And that required a little bit of NLP, so parsing of the trees that represent the chemical compounds, combined with a few other things, so named entity recognition. We used taxonomies as well, taxonomies created in-house to make sure that we were capturing not just the compound names, but the classes that they may belong to. And at the end of the day, we were able to create a pretty accurate pipeline to extract compounds from patents and from scientific text. At the end of the day, this is the cool thing. Without dropping inaccuracy, we were able to go from 450 files per year to over 16,000 files being scanned per year. We had the ability to process 168,000 documents, 1.7 million compounds per year instead of 0.4. We actually also were able now to extract information from non-English text because most of our annotators, they were English. They understood English documents, so they weren't touching the Spanish and the Chinese documents. And the cost per compound dropped 85% in the first year. So that's massive, without affecting the quality of the excerptions, without affecting the quality of the compounds. So after this, we were, super excited. What else could we use this for? So the second use case had to do with funding bodies. So in research, a lot of the work is driven by funding agencies, grant money that funding agencies give to researchers to actually help them advance their science. And one of the proxies that funders like to use to measure the output of the funding money that they're giving the organizations and the scientists is through the number of papers. But there's no standard way to document in a paper where this money comes from. One proxy we use is the acknowledgement section. Scientists will often say, thanks to the NIH, grant money, da-da-da, grant number, da-da-da, and that's generally how scientists report the grant, the funding agency that funded their research. But not all of the funding agencies appear in the acknowledgements. In many cases, they show up elsewhere in the text. And so our contractors were only looking at the acknowledgement section, and they were paid to essentially extract this information, both the grant ID and the funding organization, from the acknowledgement sections. So we figured there has to be a better way to do this, right? And it has to be boring work, right? To just spend your entire day going through acknowledgement sections and try to identify the funding agency that gave you that money. So we looked at documents from Scopus, which is another big database that Elsevier has. We extracted funding bodies, grant IDs, and the relationship between them. So our approach was, again, a support vector machine. We like support vector machines. And we started by classifying the text into whether it does have funding information or not. And that is an even easier problem than to ask whether a sentence has compound or not. So pretty good accuracy in classifying the text. And then what we did next is, because we couldn't pick an annotator, they all did well in different scenarios. So we built an ensemble method. What that means is we get all of the annotators that we can get our hands off to vote on what they think the funding agency is and what they think the grant is. And the result of that vote is what we end up extracting from the text. So whoever gets the biggest vote is what we end up saving on the database. So that was kind of cool. So nowadays, you can go to one of the Elsevier sites, one of the Elsevier papers, and the funding agency, the funding section is there. So the funding agencies can actually go to our database and count how many times their organization and their grants are cited in Elsevier papers. So in terms of outcomes, pretty good F-scores. So we went from 48% to 80%. And this is mostly because of the recall. So we didn't touch the precision. So the precision remained the same. But because now we were able to find funding organizations in the whole text of the article, we were able to really bring up that F-score. And that was really powerful for us, because now more funding agencies want to work with us because we've got such great data for them to work with. Annual cost went from 150,000 euros per year to a little under 5,000. In terms of IP, we were actually able to create a patent around this process, whereas before, we kind of relied on the contractors to figure out their own process and to figure out what needed to be done to ensure quality. So all in all, it was worth the investment we made in making this transition to automatic. And last but not least, let me talk a little bit about a project called Topic Pages. So a lot of our customers, we're facing this wealth of literature. There's a massive amount of papers that are coming out every year, not just papers, publications, information that's being generated by people. And many of them, in particular PIs and scientists at the top of their fields, needed the ability to quickly grasp topics, to get familiarized with the topic really quickly, either because the funding agency they were used to working with is now funding this particular topic, or in the case of specialists, doctors, they need the ability to learn as much as they can about patient's diagnosis so that they can be confident they're making the right decisions. So we had this challenge, and we knew we had massive amounts of information about a variety of topics, but it was dispersed. It was all over the place, essentially in textbooks, in papers, in guidelines. And so the first thing we did was we built a taxonomy. What kind of things do we want to capture information about? Essentially, we started thinking about how to organize knowledge in a way that's different from the way knowledge is traditionally organized. Once we had this taxonomy, we were actually now able to use standard NLP techniques like named entity recognition, entity identification, etc. And then the final step is how do we scale this? Because we've got 16 million individual articles. This is a massive amount of data. So investing on technology that can scale was actually pretty critical. In this case, we use Databricks and Apache Spark, and that helped us scale. But at the end of the day, what we have is something that looks like this. If you go to Google nowadays and you search for a medical term that doesn't tend to show up in Wikipedia, things that haven't actually been annotated in Wikipedia, the top result you get in Google is one of these topic pages. And they're all dynamically generated. There's no manual curation going on here. So you click on the page and you get something like that. It tells you that this is the topic page about amygdala, and it also gives you snippets of text from the various sources that it was able to find in order to support the information that it's giving you about the amygdala. This is a free layer of content, actually, so you don't need an Elsevier subscription to get access to most of these topic pages. And it really has done a lot for our visibility, for Elsevier's hit rate. So this is the number of clicks we've had in our articles since topic pages were created, and it's still growing exponentially. These numbers are not cumulative, they're raw. So it was extremely important for us to put out this Science Direct topic pages. Nowadays we have about 330,000 topics in 20 domains, 10 million visits per month to the topic pages. It drives 13% of Science Direct traffic, and 78% return user rate, which is pretty fantastic, I should say. So in order to implement these type of things in your organizations, what should be the guiding principles? What type of strategies should you follow in order to make something like this happen inside your organizations. So, Michelle's qualified to do this. I'm not, but I'm going to try anyway. So here's the thing. You need very close collaboration with product. So it's not enough to tell product, we're not going to automate the stuff that you guys do and then go off and do it. No, you need to work very closely with them because they're the experts. They know exactly what the data should look like. They know exactly what their customers are expecting in terms of quality. So if you go off and you do things independently from the product, you're not going to go far. And the second thing is that you need is a close collaboration with technology. Because technology, the TIO or Tech Ops, knows how to work with the stack of software. So if you deviate too far off from what they know, it'll be nearly impossible for you to put things into production. So work with them, understand what they need, understand what they know, and train them if you need to. So if they've never deployed a Python-based stack into production, help them figure out how it's done. Stay close to your production systems, right? Use these techniques to improve your customer outcomes. Let the customer needs drive what you do to get there. Stay close to production data, of course. If you want to play around with mocked-up data, that's fine. But the closer you can get to actually working with production data, the better off you're going to be. Because you're going to find all sorts of edge cases and all sorts of exceptions that are going to break your model if you didn't count on them, if you didn't take them into consideration. Engage with the AI community. So our team regularly publishes in ACL, publishes in the very large data science conferences. And this is not just motivating for the folks who work at Elsevier. It also gets the word out there. It also increases Elsevier's profile in the AI community, right? People will know that Elsevier is actually very invested in machine learning and data science. It also, sending scientists, sending your developers to these conferences, they come back with a lot of standard best practices that they would not know about otherwise. We use a scrum of scrums for shared learning. So we try to align senior and junior engineers so that we have a very good knowledge transfer going on during the Scrum teams, and reuse the APIs across teams. Many times you don't need to be rewriting and rebuilding APIs for every product that you build. So try as hard as you can to reuse APIs that have been written for other purposes, and see if you can generalize your API so that you don't have to rewrite them again. So in conclusion, you need support from the top, right? Without that, you're not going to go far. And when I say support from the top, it means the CEOs and the CIOs need shared responsibility. They need these innovations to be part of their OKRs. Otherwise, this is not going to work. Sometimes you have to make tough decisions, right? If we're automating what our contractors were doing for us, it also means we're letting go a lot of contractors that maybe we've worked with for 20 years. So these tough decisions need to be made. They're strategic decisions. Resource, you need to figure out where the money is going to come from in order to fund this type of teams. Change management, and that is one of the hardest things to do. We're still in the process of changing mindsets. A lot of our employees are editors. Their job on a daily basis is to get papers and review them and tell the author whether the paper is accepted or not. So we're retraining the entire staff on machine learning and data science. So we've got programs across the whole organization to train our employees to know how to write code, to know how to do data science. Organized for success. So our company is distributed. We've got offices all over the world. So we try to make sure we can still work in a decentralized environment. The biggest challenge, of course, is time zones. But we got people in Singapore, we got people in San Francisco. But we try to make sure that we're constantly in communication and that the right people are talking instead of just relying on direct management and hierarchical roles. And expertise, hire if you can. If you can't, train them. And our engineers are very, very passionate. And the fact that we have a great mission, of helping scientists and helping doctors make the best decision for patients is partially is what motivates a lot of our engineers. It's what motivates me as well. And demonstrate impact. Pick the low-hanging fruits, right? Build from there. Don't try to tackle it all at once. Start small. Try to identify what can you solve today, and then what can you solve this week? What can you solve this month? Right? Don't try a big bang approach, because those generally don't work. Start small and build your way from there. Convince your senior management team as you're building it that it's worth investing in these techniques. And overall, I think one of the key points is just have fun. It's more fun to automate things than to do them manually. So, that's it for me. Thank you.
Okay, thank you. So we do have time for questions. Actually, I had a question.
Sure.
When yesterday's keynote speaker, Michael Stonebreaker, was talking about how companies with all these multiple supply chains and so on have some difficulties. And you touched on this a little bit with your, they took that slide down, the centralization, decentralization.
Yeah.
And as you point out, Elsevier is everywhere. Michelle was going to come in from Amsterdam. You're here in Boston. But how do you get this whole idea of data science around to all of the different geographically dispersed components of the company? Obviously the time zone, but is there also a cultural difference that plays into
Definitely. And part of this reinforcement comes from the top. So our CIO is constantly reminding us that the world is changing and we need to adapt. But there's also a lot of bottom-up self-organization. So we use Slack all the time, and we have guilds, we have channels that are dedicated to talking about machine learning and deep science and deep learning. We organize lunch and learn talks in the individual offices so that people are made aware that these things are coming. I mean, essentially it becomes entrenched in the culture, being able to do this type of work. So it has to come from the bottom up. It's not always top down.
Other questions for Helena? Way in the back there, yeah.
Sorry, what was the price?
Overall price for. Okay.
I don't know. I don't know, to be honest. A lot of ontologies are actually, we start by borrowing them from publicly available ontologies. So in the health space, for example, we borrowed the UMLS ontology, and that includes things like ICDs, NOMAD. So once we have those in-house, we start thinking about how we can use them to support the various products and the various needs. Yeah, Jupyter Notebooks. I think it's the easiest way to get started. Most books that teach you Python will actually teach you how to install and deploy Jupyter. Once you go into production, then things are different. But getting people on board with using Jupyter Notebooks, it's actually pretty important.
What would you say was your transition time from working with the different subtractors to actually getting to a point where now you're relying on the machine learning?
It varies from project to project, but you have to account for at least 1 year. It's going to take time, especially because it's going to be an iterative process. Because you may be able to build a model in 2 months, but then as soon as you put it in front of your customers, they're going to find all sorts of little problems that you didn't account for. So it's the traditional, 90% of the time is spent those extra 10%, that extra 10% of the work. So you have, at least 1 year.
Actually, 1 year doesn't, that sounds short. Is that really?
It depends on how complicated your process is, yeah.
So I think it would vary a lot by project and by...
Definitely.
Yeah.
Definitely. But if you've got support from the top, things go much faster.
It always sounds good to say you need support from the top. In the real world, that's not so easy all the time.
Very true. That's why those low-hanging fruits are important.
Other questions for Helena? Oh, sorry. Stand up. Stand up so we can see.
Okay, I was wondering if you implemented any data governance strategy. Did you have any sensitive data or any policies that you needed to follow for your data set?
Yes. So we have to respect GDPR.
Does everybody understand what GDPR is? Do we need to explain that? General data protection?
Okay. Well, the European Union last year put out a set of regulations about how private data, how personal data can be used. So we did have to deal with GDPR for sure. So the question was about data governance. Did we put a data governance effort in place? So we built data governance from the ground up. So product by product. We didn't try to go at it from a comprehensive top-down approach. We ask, what do we need to standardize for every product, for every need? What do we need in terms of data governance, right? Keep the scope limited. Know exactly what problem you're solving. Know exactly what challenge you're tackling, and solve that. Don't try to solve the problem for every product in the company. Identify the challenge, identify your strategy, and pursue that. Yes, you may end up siloing your data, but at that point, then you do have people who know that data very well and who can make the bridges to the other products.
So I was curious how you approach deployment of models versus the model performance, in the sense that you won't be 100% accurate, and for the times you are wrong, let's say information on compounds, you run the risk of presenting something to your end customer that's maybe not correct information, but you have to deploy at some point.
Right.
So how do you approach that?
We let our users tell us. So almost all of our portals have a feedback button. Of course, we also do QA internally, but we let our customers tell us what we're getting right and what we're getting wrong, and then we use that feedback to improve the accuracies.
Generally, the engagement from end users, you have seen that whole system is...
Oh yeah, especially when they're upset.
So is that usually what happens with the feedback button? Is it because
Yes.
people are... And you get a lot of feedback on the feedback
Yes.
button? Yes, okay. Does anybody say, yes, you're exactly right, thank you?
Sometimes.
Sometimes.
But it's more often than not. It's what I was searching for didn't come back. So but you're always going to have negative reviews. So best thing you can do is learn from it.
Yeah.
Right?
Other questions for Helena? Curious, how many of you are using Jupyter Notebooks? Maybe half? Okay. Maybe that's something we should look into for next year's program. Yeah? Okay. I'll take that on board. Feedback, see?
Exactly.
Anything else for Helena? Okay, join me in thanking her very much.
Thank you.